Hello everyone, Mr. Tomashik here. Today I want to talk to you about acids and bases. Here's a bottle of hydrochloric acid. We had talked about this one time before. Before we start though, let's see what Google has to say about a definition of what are acids. Here's a definition of acids: a chemical substance that neutralizes alkalis, dissolves some metals, and turns litmus red, typically a corrosive or sour tasting liquid of this kind. Now there's some pictures here, a little bit hard to see them, but this is trying to illustrate acid rain. You probably have heard about that before. Here's a pH scale. Here's a diagram showing corrosion. This is a picture of some kind of a sculpture that's been affected by acid rain. Now, if you remember back when we did the lab called determination of R, and we actually did a reaction where magnesium metal reacted with hydrochloric acid. Let's watch that one more time.
Hydrochloric acid is a strong acid. We'll learn more about that later in this year. What I'm going to do is take a little bit of it and put it into this test tube. And then we're going to add a little piece of magnesium metal to it. This will be the reaction we actually do in this experiment. I'm going to ball it up a little bit so that it can go down there. And you can see that it reacts quite readily with the hydrochloric acid. Now this is a reaction we're going to do in the lab. It's going to produce aqueous magnesium chloride, which will stay in the test tube, and hydrogen gas, which is right now just floating away out of the test tube. In our experiment though, we're going to try to collect that hydrogen gas and measure it. So that's the reaction that we're going to do. All right, again, it's going to be magnesium plus hydrochloric acid, and that's going to give us magnesium chloride. That's going to stay aqueous, and hydrogen gas, which are these bubbles that just go right up out of the test tube here.
There you go. That was the reaction that we did in that lab called determination of R, the ideal gas constant. Now the formula for hydrochloric acid is HCl. All right, now they also describe some other properties here, but let's take a look at chemically what is an acid. Here's one very simple definition of an acid. An acid is any compound when dissolved in water puts H plus ions into the solution, whereas a base puts OH minus hydroxide ions. So we call that right there a hydrogen ion and a hydroxide ion. Now notice those two ions come together to make up HOH, or better known as water, H2O. So water contains these two ions to a small extent like that, but it's all about these ions that make up what we call acids and bases. An acid has the H plus ions in it, and the bases have the OH minus ions in it. So here are a couple of the more common acids. HCl is known as hydrochloric acid. When it's dissolved in water, it turns into H plus ions and chloride ions. Here's another one, H2SO4, that's known as sulfuric acid. When it dissolves, it makes H plus ions and SO4 2 minus sulfate ions. Here's one called carbonic acid, H2CO3. When dissolved, makes H plus ions. So notice that if a compound dissolves in water and it makes H plus ions, that what constitutes an acid. Now the other stuff, that's just kind of a side thing, but the important thing to call it an acid is this H plus thing here. Now on the other hand, bases are compounds that when dissolved make OH minus ions. For example, sodium hydroxide or magnesium hydroxide. When they dissolve, they make OH minus hydroxide ions, and that's why we call them a base. So in general, any time you dissolve something into water and it creates H plus ions or OH minus ions, it's either an acid or a base. All right, that's a kind of our definition of what that is. Now, what are some of the properties of acids and bases we'll look at here in a minute. At this point, though, it might be important to note that water itself, HOH, let's write it as that, it can ionize, self-ionize, and turn into H plus ions, and also OH minus ions. Now, water does this to a small extent, and because it makes H plus ions, you could consider it an acid. And if it makes OH minus, you could consider it a base, but it's kind of both acid and base at the same time. So the fact that it's both of them, it's kind of neutral and doesn't really have the properties of an acid or a base. But if we throw something else into the mix, then we can change the amount of H plus or OH minus ions, and that's what happens when you make an acid. Also, these H plus ions, really, that's just a proton. That's just a proton, a hydrogen ion without its electron. And they don't really like to just float around freely in the water itself. So what really happens is that H plus ion will hook up with another water molecule, H2O, and it will turn into what's called hydronium ion, which will then have a 1 plus. So rather than floating around freely as a plus ion, 1 plus ion, hydrogen ion, it connects itself to a water molecule and turns into a hydronium ion. So really, acids contain this hydronium ion. These H plus ions don't really float around freely in the solution. They always turn into this H plus ion. So we'll see later when we talk about pH that it's related to how many of these H3O plus ions are in the solution. All right, but they're basically the same thing. If I have 100 of those in the solution, then I really have 100 of those in the solution. They really are the same thing in the solution. If we were to look closely at some acid like this hydrochloric acid, what it looks like is water. You can't really even tell that there's anything dissolved in that water at all. So to consider its property, we'll have to do something else besides just look at it. So here's a list of some of the properties of acids and bases. Let's consider most of these. Now, on your test, we are going to want you to know these particular properties of acids and bases. All right, it'll either be like a multiple choice question or some kind of a matching question, but study these properties and learn them. Now, number one, or the top there, is that acids are corrosive. What does that mean? That means if you get it on your skin or in your eyes, it's going to destroy your skin and your eyes. Notice, both of them are corrosive. All right, so both acids and bases are corrosive. Now, how corrosive? Well, that depends on what acid you're talking about. Some of them worse than others. Some acids are not very corrosive, and in fact, you can actually eat them, like in lemons. Lemons has citric acid in it, and that is what makes stuff taste sour. So notice on the acid list that acids taste sour. Now, of course, you're not going to want to put like this, 3 molar hydrochloric acid on your tongue because it will destroy your tongue. But you could put, the juice from lemons or vinegar or something on your tongue, and it would taste sour. If you left it there sitting for a long enough time, though, it would probably destroy your tongue and your teeth, for that matter, too, as well. Now, what about bases, though? Bases tend to taste bitter. And these would be things like unsweetened chocolate. Kale is sort of weird looking lettuce. Soap, if you've ever had soap in your mouth, and sometimes when you're young and you say naughty words, you get soap in your mouth. And we all know that it tastes bad. Now, down here on the left is sort of the universal symbol for something is corrosive. And if you spill it on your finger or your hands, it can actually destroy your skin and your eyes. So always wear goggles. Next on our list, it says that acids put H plus ions into a solution. Bases put OH ions into solution. All right, we just talked about that. That's kind of our definition of acid. Next, it says turns litmus red, and then bases turns litmus blue. Now, what is litmus? Litmus is an indicator. It's a chemical that changes color whether it's put into an acid or a base. All right, remember this. Litmus is red in acid. Litmus is blue in base. Okay, let's take a look at what I'm talking about. I have here some what we call litmus paper, and it has that chemical soaked into the paper, and then the paper is dried out. Now, the fact that one paper is blue is that it's sort of been, has a little bit of base mixed into it to start with, just to make it blue, and then this one had a little bit of acid mixed into it to make it red to start with. Now, if I put acid on this, the red one should turn or stay red, and the blue one should turn red. Now, if I put a base on each one of them, the blue one will stay blue and the red one will turn blue. All right, now, where around your house could you find some acid? Probably the most common household chemical that is acid is vinegar. All right, distilled white vinegar. You probably have some of that in your kitchen. Use it for cooking and stuff like that. And then for base, bleach. Most of you probably got bleach. All right, those are some very common chemicals that are around your house that are acids and base. All right, let's put a little bit on the litmus paper. Okay, first let me get a little drop of the acetic acid or vinegar. I'm going to put that onto the blue litmus, and notice what happens. It turns red. I put a little bit of it onto the red litmus paper, and it doesn't really change color. All right, so acid on blue makes it red, and acid on the red keeps it red. All right, let's do the same with a little bit of the bleach. All right, let me start with a fresh piece. Okay, a little touch of bleach on the blue, and the blue stays blue. A little bit on the red, and the red turns blue. So with base, blue litmus stays blue, and the red litmus turns blue. So in base, like bleach, litmus is blue. Okay, last on our list of properties is pH of less than 7. Now, we'll talk a little bit more about what pH is a little bit later, but it's a measurement of how acidic acids are, or how basic, or sometimes we use the word alkaline to represent base. And it goes on a scale from 0 to 14, whereas if you are less than 7, you would be acidic. If your pH is greater than 7, then you would be considered basic. Well, what would be the pH, or what would you have if you had a pH that was actually equal to 7? All right, that would be what you'd have if you had distilled water. Distilled water, which is another chemical you may have at your house. Sometimes people buy a jug of distilled water and use it for things like putting in your iron, for ironing your clothes. All right, it's not necessarily good to drink because it doesn't have anything dissolved in it. And water without anything dissolved in it doesn't really have much flavor, and most people say it doesn't taste good. So you buy it not to drink, but to use in things like your iron, for ironing clothes. Now, in addition to these general properties, there are also a number of acids and bases that are very common around the house or around the everyday experience that we want you to get to know as well. But as far as this goes, learn these properties of acids and bases, as you might find questions on the test related to that. All right. Now, what are a few very common acids that you find probably around your house? A lot of them. And here's a short list. There's lots more acids than this, and when you go on and take biology, you'll probably talk about different kind of acids there as well, like deoxyribonucleic acid and parts of DNA and stuff like that. But some very common acids. Now, what we want you to do is know the formulas of these, and hopefully you can kind of just look at that and say what the formula is, and then their common acid name, which might be different than their formula name, and then where you might find it. All right, let's look at some examples. HCl, which chemically speaking would be hydrogen chloride, but as an acid we call it hydrochloric acid, and that's the kind of acid that's in your stomach. So this is another thing we want you to study, is this chart. But let's take a look at each one of them one at a time. First, let's talk about this pH scale. We'll be talking about this a lot more later, but here it shows a bunch of different chemicals that you might find around your house, like lemon juice, tomato juice, milk, baking soda, and it shows the pH number of each one of these things. Notice here then that a pH of less than 7 are acids, and pHs greater than 7 would be bases, and then pH of a 7 is just pure water, all right, or water without anything dissolved in it. All right. So if your pH gets very large over here, these would be more corrosive, and if your pH gets really low, these would be more corrosive here. All right. Now notice that lemon juice is a pH of 2. That's quite corrosive. Literally, if you ate lemons straight away every day, you'd probably have some serious problems with your teeth because acids can destroy your teeth. All right, let's look at our list of the ones that we want to know here. First off is hydrochloric acid, HCl. Now, this is the kind of acid that's in your stomach. All right, stomach acid. Your body literally makes it. So the cell walls, the lining of your stomach, excretes the H+ ions and the Cl- ions into the solution that's in your stomach, and it makes stomach acid, which is a very strong corrosive acid. Fortunately, though, the lining of your stomach can actually handle that. Now, if the acid were to come up your esophagus, to your throat, your esophagus and your throat and your tongue and your mouth can't really handle that acid very well, and it could be a serious problem. All right, so there's a little valve right here that kind of keeps the acid from coming up, but sometimes people do have problems with that, and the acid sort of creeps its way up your esophagus, and that's what we call heartburn. And when you get that, then you have to take antacids, basically some kind of a base that will neutralize that to keep it from destroying your esophagus and your tongue and your teeth, like that. Now, if we put this in acid, of course, red litmus is going to turn red. Now, where could you actually buy it? You can buy it at the hardware store, and it's known as muriatic acid, and sometimes people use that to adjust the pH of their pool, or sometimes painters use it when they want to paint brick, because you want to clean brick with this acid before you actually paint it. All right. Other than that, it might be in very dilute amounts of stuff around your house, but not the most common acid that you might find just around your house. Second is sulfuric acid. Now, sulfuric acid, again, not commonly found all over the place, but it is the kind of acid that you find in a car battery. All right. When we refer to battery acid, that's what we're talking about. Now, not all batteries contain acid, but a car battery does, and it's a very strong corrosive acid as well. Let me show you a short video about car battery acid. Right now we're underneath the hood of my car because I want to show you the car battery, which contains sulfuric acid. This particular battery has 6 different cells. Each one of them has its own little air vent, and we can take the cap off of the air vent and look at where the acid is inside. It's a little hard to see, but down in that hole you can see there's battery acid in there. Now this thing lets air in and out of the battery. Couldn't have it sealed, otherwise the thing might actually explode. So interesting point that you should know about a car battery, though, is if you tip it over, these little tiny holes that vent air in and out of it can actually leak battery acid. So you don't want to tip over a car battery, or it will leak its acid. Now what we're going to do today is test the charge in it using this device called a hydrometer. What does it measure? It measures the specific gravity of the acid inside the battery, and that's a way to tell whether the battery is charged up or not.
And specific gravity is just a ratio of the density of the acid to the density of water. So if we had a specific gravity of, say, 1.300, then they would be 1.3 times heavier than water. And that can tell us that the battery is charged or not charged. So what you have to do is take the cap off, suck some of the water out of there, or suck some of the acid out of there into this little thing, and then it can tell you. Let's try it here. All right, when we do this, we want to for sure have safety goggles on and some hand protection as well. And what we'll do then is take the cap off one of these cells, and we'll draw some of the acid out of the battery by dipping this down in there. It has a little plunger. I squeeze the plunger, then I can draw the acid up inside of the container. There's a certain level that it's supposed to get up to, right there. All right, let's take a closer look at this. You can see the level, and there's a little line that it's supposed to be up to right about there. And there's a little gauge on the side here, and the needle is somewhere between 1.2 and 1.3. So the charge on this battery is good. Not all the way to the top, but fully charged. And then we just squeeze the acid right back down into the battery. Like that. You gotta be very careful not to get that on your clothes, or that'll eat a hole right through your clothes and your skin. Sulfuric acid is a very strong acid. Then we'll have to rinse this thing out. A hydrometer for battery testing. Since we're looking at the car battery, let's look at one other electrical device related to the system. Is this thing right here. This is called an alternator. What does it do? It's a generator that recharges the battery each time you use it. So when you start your car, the battery will get drained a little bit, and then the gasoline engine will take over and run this alternator, and it will recharge your battery. An alternator. If your alternator goes bad, you'll know it because your battery won't charge. You won't be able to start your car. Since we're under the hood here, let's talk a little bit about some car stuff. This right here is the positive terminal. It usually has a cap on it because the negative terminal is usually connected straight to the car itself. So anything that's metal on the car is actually connected to the negative terminal. So if you touch the negative terminal and the positive terminal at the same time, you're literally connecting to the battery. And if you are touching the positive terminal and any other part of the car at the same time, like right here, you are connecting straight to the battery. However, in this case, I don't get a shock because the amount of current is so small, I don't feel anything to it. Though if we were to take something with a lot less resistance than myself and say hook it to the ground, which is the negative part of the battery, and then touch that to the positive terminal, we might get a little bit of current out of it. Let's watch here. You can get a lot of current from a car battery. In fact, this one here, hard to read underneath there, but this one is rated at 490 amps, which if I connected this wire to it and kept it connected to it, probably would melt the wire in short order.
The next acid on our list is carbonic acid, which has that formula H2CO3. H2CO3 also could be called hydrogen carbonate. Now, carbonic acid you find in a lot of places, but particularly in soft drinks like Coke and Pepsi and RC Cola. It tends to give the sodas a sort of sour taste to it because acids somewhat taste sour. But you can find carbonic acid in acid rain because it reacts with when carbon dioxide reacts with water, it can turn into that carbonic acid. So it's kind of a very natural occurring type of acid that we find all over the place in different things. Even in your blood, for example, has some carbonic acid in it. Not a super strong acid, but an acid just nonetheless. Next, we have acetic acid, which is the acid that you find in vinegar. Most of you probably have vinegar in your house somewhere. The formula for it is HC2H3O2. That part of it that's called C2H3O2 is called the acetate ion. So this could go by the name of hydrogen acetate, and it's better known as acetic acid. It's the acid that's in vinegar, and we use this for all kinds of cooking purposes, and it tends to give food sort of a sour taste. Pickles and anything pickled like olives and stuff like that are usually pickled in a bit of vinegar, and if you've ever tasted pickles and olives and stuff like that, you get kind of a sour taste from them. All right, if you went to the grocery store, you could literally find all different kinds of vinegars. It's very, very popular, and it's used a lot for, to add flavor, of course, but it also works as a preservative, and it can keep stuff from getting rot. That's why you can have a jar of pickles stick around for a very long time, and they don't go bad because they're immersed in acid, and acid tends to fight off things that grow like bacteria and stuff like that too as well. This acid is nitric acid. Now, you probably won't find nitric acid in anything around your house. It's kind of rare to be used as in any household chemicals, but a very important acid industrially. It's used to make all kinds of stuff. Its formula is HNO3, or you could call it hydrogen nitrate, and it's a strong acid, and generally it's used for making things like explosives like dynamite and TNT, things like that. There is a blend. If you take some sulfuric acid and nitric acid and you mix it together, it makes a compound or a chemical known as aqua regia, which is a super, super strong acid, and that can even dissolve gold, which doesn't react with very many things. So for our purposes, just remember the formula, HNO3, nitric acid, and that it's used to make explosives. There won't be any more than a question about that. These little innocent looking pellets that look like plastic are anything but that. This is one of the most common bases, sodium hydroxide. They often come in this pellet form, but they can also come in a powdered form too as well. When it's dissolved in water, the NaOH, the sodium hydroxide, actually dissolves and makes that hydroxide ion, which is characteristic of bases. So sodium hydroxide, which also sometimes goes by the name of as lye, can be found at home in what's called oven cleaner. Now this is actually probably one of the most hazardous chemicals that you might have in your house. All right, if you read it, it recommends that you definitely wear gloves and goggles when you use it. So if you ever do use this stuff, be aware that it can be very, very nasty to get on your skin and very nasty to get in your eyes. And a lot of times people will spray it in their oven, and the fumes literally will just make your nose hurt like crazy. And a lot of people don't like using it at all just because of that fact. But keep that in mind, that that's probably one of the most hazardous chemicals that you might find in your house. So find that and tell your parents about that, to be very careful with that particular stuff. All right, in the old days, we used to use it to make soap. Make soap is one of the ingredients that you mix with animal fat, and it actually makes soap, like hand soap, bar soap. Another chemical you might find around the house that contains this sodium hydroxide is drain cleaner. Probably the most popular is this Drano, and people use this to unplug their drains. So you got a sink that's backed up. They advertise that all you got to do is pour this stuff in, and it breaks the clog and unplugs your drain. The problem is it does not always work, and it's extremely hazardous. You do not want to get it on your hands. You want to wear a respirator when doing it, and face and eye protection for sure. And if it doesn't work, now you might have a sink full of hazardous chemicals that you have to try to get rid of. Plumbers really dislike this stuff because, one, if they come into a house they have to fix, they often got pipes that are full of the stuff, or the sink is full of the stuff, and they got to use a lot of precautions, and it can be bad for your pipes too as well. So another hazardous chemical you might find at your house that you need to be aware of, that between this and the oven cleaner, these are probably the two most dangerous chemicals that you might have around your house as far as that goes. Now, magnesium hydroxide, which is just a white powder, has the formula MgOH taken twice, magnesium hydroxide. Now, remember when we talked about that stomach acid could find its way up your esophagus and into your throat and stuff like that. To counteract that, sometimes people will actually consume this stuff. Magnesium hydroxide comes in a solution known as milk of magnesia or Mylanta, and these are what we call antacids, and they actually neutralize acid. So if you have that acid reflux coming up your esophagus, or you get a stomach ache, you can take this stuff, and it's sort of neutralizes the stomach acid. Other medicines you might use for the same purpose would include Alka-Seltzer, Rolaids, or maybe even Tums. Rolaids actually contains some magnesium hydroxide, but it also contains a compound called calcium carbonate, both of which are bases and can neutralize the stomach acid. The Alka-Seltzer, on the other hand, just contains, let's see, what does it have? It has sodium bicarbonate, which is baking soda, which we'll talk about here in a minute. Next, we have a compound called ammonia. Its formula is NH3. Now, ammonia does have some similarities to water in that water is oxygen with some hydrogens attached. Here it's nitrogen with some hydrogens attached and one lone pair, whereas water has oxygen, a couple hydrogens, and it has two lone pairs. Both of them molecular compounds. Both of them can be liquids at room temperature. If we have pure ammonia, usually ammonia is mixed in with water, but if you have ammonia all by itself, we call it anhydrous ammonia. And it's kind of a hazardous chemical too. It can cause explosions, and it's very poisonous, very toxic, and you got to know what you're doing when you're handling anhydrous ammonia. Farmers sometimes use it to put on their fields as fertilizer, because a lot of it can create nitrate compounds, which is what fertilizes the soil. So farmers will often use anhydrous ammonia. But because of its hazards, you got to have special permits to utilize it. Sometimes it can be used to make explosives too as well. So it's closely guarded chemical. Diluted down, though, put into water, and you've got the ingredients in Windex, which you maybe have at your house, used for cleaning glass, like that. It has a very distinctive odor to it. Of course, anhydrous ammonia would be very nasty, and you wouldn't want to breathe that. But in a diluted state, you can smell it, and it's probably not going to destroy your nose unless you smell a lot of it. All right, for our purposes, just remember this: a lot of cleaning products, and particularly Windex, has ammonia in it, and it can also be used for fertilizers too as well. All right, last on our list is sodium carbonate or sodium bicarbonate. Now, these two are fairly closely related. Notice their formulas are only slightly different. Sodium carbonate, Na2CO3, and sodium bicarbonate, NaHCO3. whereas HCO3 is the bicarbonate polyatomic ion, and CO3 with a 2 minus is the carbonate polyatomic ion. Now, probably a lot more common is the baking soda, which is the sodium bicarbonate, and I'm pretty sure everybody has some of this in their house used for baking all kinds of stuff. Sodium carbonate doesn't have quite as many uses, though you could use it for baking, but it's kind of an old school sort of washing detergent used for cleaning purposes there. Now, why would one use baking soda for cooking? If you've ever made pancakes, you might have noticed the little bubbles that form while the pancakes are cooking. What you're witnessing there is the decomposition of baking soda. And one of the products that it decomposes into is carbon dioxide. And those are the little bubbles that you see going up there. It helps give the pancake sort of a fluffy texture to it. A similar kind of thing happens when you make muffins. You might notice on the inside of muffins, it's got a lot of little holes inside there. Those little holes are what made it kind of fluffy and rise, and that's from the carbon dioxide when the baking soda decomposed. Now, the baking soda itself might give a little bit of flavor to the ingredients, but the main reason is to make these little tiny holes in there that make the stuff rise. So baking soda is generally used to make stuff rise. Now, one might ask, why did we include sodium carbonate and sodium bicarbonate on a list of acids and bases? Because it doesn't have the H's out in front like all the acids do, and it doesn't have hydroxide ions like all the other bases do. But when you dissociate this stuff into water, it does react with water, and it increases the OH concentration in the water, and therefore turns the water into a basic solution. So these compounds we tend to include with a list of bases, because when put into water, into solution, they do make a basic solution. And sodium bicarbonate or baking soda often is used to neutralize acids sometimes. In fact, that Alka-Seltzer we looked at a moment ago actually contains the stuff, and it's used to neutralize stomach acid, and it can neutralize other acids too as well. So if you spilled a bunch of vinegar around, you could throw some baking soda on it, and it would neutralize it as well. In fact, many an elementary school science demonstration has been done by mixing vinegar and baking soda. Take, for example, this guy who has a YouTube channel called Ryan's World.
One. Whoa! It's coming out!
Whoa!
Volcano!
A blue volcano!
Welcome to Ryan's World!
Hi guys!
All right, I'll leave that for you. Go check it out, Ryan's World. 25.1 million subscribers. Way to go, kid. Let's watch one more demonstration of vinegar and baking soda. Okay, let's do the classic vinegar and baking soda experiment. We're going to do it like this. We have a little water bottle with some vinegar in it, and inside of the balloon is a bunch of baking soda. To perform the reaction, we just lift up the balloon into the baking soda, and voila, carbon dioxide bubbles blow up the balloon. Vinegar and baking soda producing carbon dioxide. There you go. Try that one at home. Okay, let's recap what you need to know for the test. Now, what you should study is this chart. All right, all these properties of acids and bases right here. Remember that they're both corrosive, and what that means. Acids taste sour, whereas bases taste bitter. Acids put hydrogen ions into solution, which eventually turn into hydronium ions. Bases put OH hydroxide ions into solution. Acids turn litmus red, and we'll talk about that in the next video too. And bases turn litmus blue. Acids have a pH that's less than 7, and bases have a pH that's greater than 7. Pure water has a pH of 7. We sometimes refer to that as pH neutral or pH balanced. Also, you need to know the information on this chart. On the test, it is probably going to be either a matching or a multiple choice kind of question, so you won't have to write the formulas, but you will have to be able to match up the names with the formulas, and the names or the formulas with this piece of information where you might find it, just the stuff on this list. All right, so study that kind of business right there as well. Baking soda. We can skip washing soda, we won't put that on there, but study all these things. All right, so that is what you should get from this video, and you should study those charts for the test.